Hello students. So today we'll be in the lecture with unit 2, that is your assembly language programming. So before beginning with the proceeding to your actual syllabus, okay, just we'll have an overview of your unit 2. So from the semester end examination point of view, okay, this unit it carries a weightage of 30 marks. So two questions will be asked in part A and two questions will be in part B. Okay, so part A contains 10 marks and part B contains 20 marks. So altogether the weightage will be of 30 marks. And today we'll be dealing with the features of machine level language, assembly level language, middle level language, high level language, and 8051 addressing modes. So before beginning with your assembly level language programming, just will have a quick glance over the introduction to 8051 assembly language programming. Okay, so already we said that the computers work in binary manner, or they can understand only the programs which are written in machine level language, that is a combination of ones and zeros. In simple, we can say the CPU can work only in binary, and it can understand the binary things or the binary codes, right? For humans to write the program using the ones and zeros is a tedious thing as well as time consuming. So earlier when the computers were invented, the programs were written by using your zeros and ones, right? So although later on hexadecimal system was used as a more efficient way to represent binary numbers, but still it was time consuming as well as tedious. Then later on assembly language programs were developed that provided mnemonics for the machine code, instructions plus other features that made the programming faster as well as less prone to error. So the programs which are written in assembly language, okay, they are translated into machine level language or machine code by a program called as a assembler. Means assembler is a language translator which translates the program written in assembly level language to machine level language. So assembly level language is referred as a low level programming language because it deals directly with the internal structure of the CPU. So if you want to program the CPU in assembly level language, right, the programmer must know all the hardware details, means the internal architecture of the CPU, plus what are the registers, which are the registers which are available for the programmer, as well as the size of each registers, right? So there are different programming languages, like we have for example like basic, Pascal, C++, Java, etc. And these languages are called high level languages because in this case the programmer need not know, or programmer is not concerned with the internal details of the CPU. Like the programmer did not know the internal architecture or the hardware configuration, what are the different registers which are available, what is the size of each register, the user need not know. Okay, plus the programs written in high level language are translated into machine level language by a program called as compiler. Means we have two language translators, one is called as a compiler and the second one is a assembler. Assemblers are the language translators which convert the program written into assembly level language to machine level language, whereas the compiler converts the program written in high level language into machine level language. So coming to structure of assembly level language, okay, so assembly language program, among other things, it consists of a series of lines. Okay, so the line it may consist, so assembly language instruction, it consists of the first field is a label field, followed by mnemonic, then we have the operand field, and then we have the comment field. Okay, so whatever things have been written within the bracket, it indicates that the field is optional. The field is optional and the brackets should not be typed. The bracket should not be typed. Okay, so the first field is a label field. The label field allows the program to refer to a line of code by name, and the number of characters which are present in the label field, it depends upon the assembler. The number of characters which are supported, okay, it depends upon the assembler. For that you have to check the assembler rules, whatever the assembler you are using, what are the rules, what are the maximum number of characters it supports. And the label field, whatever the names we are using for the label, okay, there are certain rules which are to be followed. It should not be a keyword or it should not be a reserved word. It should not be a keyword or it should not be a reserved word. Okay, so it should not begin with an digit. It should not begin with a digit. Either it can begin with an alpha, it can begin with the alphabet, or it can begin with the underscore, right? Okay, the next field is a mnemonic field. So if label field is present, the label field and the mnemonic, they have to be separated by a semicolon. If label field is present, the label field and the mnemonic, they have to be separated by a semicolon, right? So the mnemonic field, the mnemonic means what you call it as an instruction which indicates, okay, which indicates the real work of the program, or which indicates which operation has to be performed on the operands, right? And then we have the operand field. So depending upon the type of your mnemonic, or depending upon the type of your instruction, either it can have a single operand, or it can have two operands. Either it can have a single operand, or it can have two operands. If there are multiple operands, then the operands, they have to be separated by a comma. Operands have to be separated by a comma, right? And then we have the comment field. So the comment field are added either at the end of each instruction or at the end of each line, or the comment can be added after a group of instructions. So if comment field is present, then always it should be prefixed, or always it has to be followed, or it should be prefixed with semicolon. So whenever your assembler encounters a semicolon at the time of assembling your program, whenever it encounters a semicolon, then the assembler ignores whatever the thing has been written in front of a semicolon. The assembler ignores it. Means whatever the thing you write in front of a semicolon, it will not be converted into machine level language. And these comment field are added to the program to make your program more readable. Means if you have a program written by you, if some other person wants to read it, or even yourself, if you want to check it after a certain duration of time, right? So if you have the comment field either after each line or after a group of instructions, so at least we can analyze, right, what is happening after each instruction, or what is the function of that respective block or group of instructions. Means simple, we can say the program will be more readable and understandable by the programmer, what the thing he has written, right? So the comment field is optional. If used, the program will be more readable. And if comment field is present, then always it should be prefixed with a semicolon. Then beginning with your the addressing modes of 8051. Okay, so with respect to a definition, we can say that the method of specifying the data in the instruction, it is called as a addressing mode. Or in other words, we can say the way in which the data operands or the data are accessible by different instructions is known as the addressing modes. Means the method of specifying the data, or we can call it as the operand in the instruction, is called as the addressing mode. And 8051 mainly it supports 5 addressing modes. They are immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, and index addressing mode. Okay, just we'll have a check over all the 5 things. So the immediate addressing mode, the addressing mode in which the data operand is a constant and it is a part of the instruction itself, is known as a immediate addressing mode. Means in case of immediate addressing mode, data is a part of your instruction, data is a part of the instruction. Okay, so normally whatever the data you have, it should be preceded by a hash symbol. Data has to be preceded by a hash symbol. For example, you have move a comma hash 27 h indicates that whatever the constant you have, this 27, it is represented in hexadecimal. It is represented in hexadecimal. By default, if h has not been mentioned, then by default it will be taken as a decimal. It will be taken as decimal. So just to differentiate between the different number systems, whether we are working with a binary, a decimal, or hexadecimal, okay, the base or the number system in which we are working, it has to be mentioned, right? Or else if I make it as just move a comma hash 27, so 27 is the immediate value, so the constant 27 which is in hexadecimal is copied into accumulator register. Then we have the second example like add r1 comma hash 45h, add r1 comma hash 45h. So as per your intel, add is the mnemonic, add is the mnemonic, r1 is the operand or is the destination operand, or I can take it as your operand 1. Okay, so r1 is a register 8-bit register, hash 45 is the immediate value, or I can take it as a second operand, right? So this 45, okay, we treat it as a source operand. So this add instruction, okay, it adds the constant 45, that is your source operand, that is constant value which is a part of your instruction, that 45 is added to the content of your accumulator. Then we have the third example like move dptr comma hash 8245h. 8245 is a 16-bit value, dptr is a 16-bit register. So the 16-bit data is a part of your instruction. Move the data or copy the data 8245 into dptr register. Move p1 comma hash 21h. Copy this immediate value 21 to port p1. Okay, so immediate addressing mode means the data is a part of your instruction. Okay, means whatever the constant value is a part of your instruction, and the constant either it can be represented in binary, or it can be represented in decimal, or it can be represented in hexadecimal, right? Data is a part of your instruction. So next, coming to the next one, that is your direct addressing mode. The direct addressing mode in which the data operand is in the RAM location, having internal RAM location having the address from 00 to 7fh, and the address of the data operand is given in the instruction. Means the address is a part of your instruction, address is a part of the instruction. So direct addressing mode uses the lower 128 bytes of internal RAM and the SFRs. So for example, move r1 comma 42h. So in this case 42, in this case we are not using the symbol like hash. This 42 now it is treated as an address. So what it does, it copies the content of your RAM memory 42 to register r1. Second example, we have move 49 comma a, copy the content of your accumulator, that is register a, to the memory or to the RAM location having the address 49, right? So in case of your direct addressing mode, address is a part of your instruction, address is a part of the instruction, right? So next we have register addressing mode. In case of your register addressing mode, the data on which your instruction operates, on which the instruction operates, lies in the registers, lies in the registers. For example, in this case, if you observe the first example, move a comma r0, move a comma r0. In this case, both the operands are the register, both the operands are the register. First example, move a comma r0, the destination operand is your accumulator, that is register a, and the source operand is your register r0. So in this case, it copies the content of r0 into accumulator, content of r0 into accumulator, that is your register a. Or we have the second example like add a comma r6, add a comma r6. So in this case, both the operands are the registers, that is your register a and r6, right? So the instructions having such kind of format, they come under your register addressing mode, and this instruction, it adds the content of r6 with the content of accumulator. Okay, then you have move p1 comma r2, move the contents of register r2 to port 1. Or we have the instructions like move r5 comma r2. Okay, this is invalid because in case of 8051, okay, the data transfer between registers is not allowed, the data transfer between registers is not allowed. Either you can copy the content of r registers into accumulator, right, or from r register to any of your ports, either it may be p0, p1, p2 or p3. Okay, but you can't copy the content of one r register to another r register, which is invalid. right? The next one is your register indirect addressing mode. So in case of your register indirect addressing mode, okay, the register is used as a pointer to the data memory block, is known as register indirect addressing mode, or in other words we can say the address of the internal RAM memory. The address of the internal RAM memory is present in the registers, right? So for example, you have, okay, move a comma at r0, the symbol indicates it is an indirect addressing mode, that is symbol at. Move the content of RAM location whose address is in register r0. Now the content of r0 is treated as an address. The content of internal RAM memory whose address is in r0 is copied to accumulator. The second example, you have move at r1 comma b. Move the content of register B into RAM location whose address is held by register R1. So in case of 8051, okay, so only two registers can be used as pointers. They are your register R0 and register R1. Okay, so when registers R0 and R1, if they are used as a pointers, then they should be preceded by the symbol at. Okay, and one of the advantages of using register indirect addressing mode is that it makes the accessing the data more dynamic than static, as in case of direct addressing mode. Then the last one, we have the indexed addressing mode. So this addressing mode is used to access the data elements of lookup table entries located in program ROM space of 8051. So for example, you have move C a comma at a plus dptr. So in this case, move C stands for move code, move a code byte. Okay, so dptr is a 16-bit register, a is your accumulator or register A. So this instruction, what it does, the 16-bit register dptr and register A are used to form the address of the data element. Okay, so in this case, first the content of your register A will be added with the content of your dptr, and the content of that resultant memory location will be copied into accumulator. It will be copied into register A. Means we can say, okay, the content of your A are added to the 16-bit register dptr to form the 16-bit address of the data operand, and mainly we are using the indexed addressing mode to access some of the data which are available in the lookup tables, in the program ROM space of 8051. So in the next class, we'll begin with your 8051 instructions. Have a good day.